Hi, I'm Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this video, I would like to discuss the question bank, which is from module number 4 of the subject Differential Equations and Vector Calculus. And now present we are in Vector Differentiation, Part A questions, and it is in second video. Now, see the problem number 1. Determine a unit vector normal to the surface x y cube z square is equal to 4 at the point -1, -1, 2. So we know that if phi is any surface, then grad phi is the normal vector to the surface. And here we have to find the unit normal vector. What is the unit normal vector? That is grad phi by magnitude of grad phi at the given point x comma y comma z. So what we have to calculate in this problem is we have to find the unit normal vector to the surface phi at this point. The point is given -1, -1, 2. Now, what is phi? Here phi is x y cube z square minus 4. And grad phi, what is grad phi? This is the normal vector to the surface. The normal vector to the surface phi, that is equal to grad phi, which is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the vector of the given function phi x y cube z square minus 4. So on operating with each term I bar into dou by dou x of entire term, that is x1 you will get y cube z square, and for the derivative of 4 that is equal to 0, plus j bar into dou by dou y of entire term. Dou by dou y of entire term is 3xy square z square, and the derivative for 4 is 0 as in the first case, plus k bar into dou by dou z of this one, that is 2xy cube z square. 2y cube 2xy cube z square, derivative 2z, xy cube constant with respect to z means partially xy cube constant, z square derivative 2z. Now, what is the grad phi at the point? What is the given point? -1, -1, 2. So at this point, what we will get? -1 whole square, 1 and -1. 1 into -1, -1 I bar z square. Z is equal to 2. Z square is 2, that is 2 square, 4. Y cube, that is -1 into I bar. 4 into y cube means -1 whole cube, that is -1. Z square 2, 2 square 4 into I bar. Plus j bar into, what is the value? 3 into x -1, y square plus 1, z square 4. Plus k bar into 2 into x, that is -2, and y cube, that is also -1, and z, that is equal to 2. So what will be, you will get here is -4 I bar minus 12 j bar, 4 3s are 12 with minus sign, 3 into x -1, y square plus 1, z square 2 square, that is 4, minus 4 into 3, that is minus 12 into j bar, and last one it is 2 into x is -1, that is -2, y cube -1 into 2, that is -2 into 2, 4, plus sign, so there is plus 4 into k bar, -2 into -1 into 2, that is equal to 4 k bar. So this is grad phi at this point. grad phi at this point. This is normal vector to the surface. Then what is our calculation is we have to find the unit normal vector to the surface. Therefore, unit normal vector to the surface phi is given by grad phi by magnitude of grad phi. That is equal to, what is grad phi? Already we have calculated. The grad phi is minus 4i bar minus 12j bar minus 4i bar minus 12j bar minus 4i bar minus 12j bar, and what is other one? Plus 4k bar plus 4k bar by magnitude of grad phi, that is square root of 16 plus 144 plus 4 4s are 16. Once again I will check it out. Minus 4i bar minus 12j bar plus 4k bar by root of 4 square 16, 12 square 144, 4 square 16. That is equal to minus 4i bar minus 12j bar plus 4k bar by square root of 144 plus 16. That is 160 plus 176. 144 plus 32. 6, 7, 176. That is the unit normal vector to the surface at the given point, which is the required solution. So if you want, you can cancel out by using 2 and in the denominator and numerator, you will get the required solution. Right. So finding of unit normal vector means grad phi by magnitude of grad phi. Next, go for the next problem. Find the directional derivative of phi of xyz is equal to x square yz plus 4xz square. This is the given surface of this. We have to find the directional derivative at this point in the direction of the normal to the surface at this point, right? So first I will write the formula. The directional derivative of phi in the direction of a bar, in the direction of a bar is equal to grad phi dot a bar by magnitude of a bar. This is the formula. The directional derivative of phi in the direction of a bar, that is grad phi dot a bar by magnitude of a bar. Here, given phi of xyz, we have to find the directional derivative of phi at this point in the direction of the normal to the surface f of xyz is equal to x log z minus y square at this point. So you have to find a bar, which is the normal vector to the surface at this point, and you have to find grad phi. You have to find two items. First, given phi, what is phi? X square yz plus 4xz square, and grad phi, the normal vector to the surface. It is the, grad phi means it is the first item, normal vector to the surface. It is the part in the formula. That is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of phi. What is phi? X square yz plus 4xz square. So that is I bar into, what is dou by dou x of entire term? Dou by dou x, the partial derivative with respect to x. That is, first one is 2xyz plus second one is 4z square. I'm differentiating partially with respect to x. X will become 1, 4z square plus j bar into dou by dou y of entire thing. Dou by dou y of entire thing. That is x square z plus 0. This entire term is no y term, that is 0 with respect to y partial derivative. Plus k bar into, the first term x square y plus with respect to z 2z 4x, that is 8 4 2s are 8xz. Z square is 2z, 2 4s are 8xz. Now grad phi at the point 1 comma minus 2 comma minus 1. 1 comma minus 2 comma minus 1. What is the value? 2 into 1 into minus 2. That is minus 4 into minus 1. So I bar into, this is plus 4. 2 into 1 into minus 2 and minus 1. That is minus 4 and it will become plus 4. plus 4z square, that is also 4, plus j bar into z is minus 1. On substituting z for minus 1, it is 4 plus 4 into I bar. Next, x square, that is 1, and z is minus 1, plus 0. And the third term k into x square y. What is x square y? X square is 1, y minus 2. So minus 2 plus 8 into x into z. So that is minus 8. 8 into x into z. X into z means 1 into minus 1 minus 1. That is minus 8. Now what it will become? 8I bar minus j bar minus 10k bar, and call this is equation number 1. Now we have calculated the first part of the problem, grad phi at the point 1 comma minus 2 comma minus 1. Now what is the second part? We have to find a bar. How to find a bar? A bar is the normal vector to the surface given at this point. So on writing finding given, if given, what I can write? Also given function of x, y, z, another function which is given x log z minus y square, x log z minus y square. So the normal vector at this point, at the normal vector to the function at the point minus 1, 2, comma 1, minus 1, comma 2, comma 1 is a bar. The normal vector to the surface at this point will be a bar. So how to find the normal vector? Then the normal to f is grad f. Normal to f is grad f. That is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of x log z minus y square. So that is I bar into dou by dou x of this entire term, that is log z, plus j bar into dou by dou y of this one minus 2y, because these two terms are containing x and z and those values are 0. Only derivative for y square, that is minus 2y. In the first case, dou by dou x of x1 log z will be there and y square derivative 0, plus k bar into dou by dou z of entire term, that is x by z, y square term 0, log z derivative 1 by z into x, that is x by z. Now grad f at the point, what is the point? Minus 1, 2, comma 1 is equal to, so I bar into log 1, z is 1, so log 1, plus j bar into minus 2 into 2 plus k bar into minus 1 by 1. That is log 1 0, 0 into I bar plus minus 4 into j bar plus minus 1 into k bar. That is minus 4j bar minus k bar, and this will be the a bar. Call this is equation number 2. The normal vector to the surface grad f at the point minus 1, comma 2, comma 1. Now what we have to calculate is the directional derivative is equal to grad phi dot a bar by magnitude of a bar. So if it is a bar, then what is magnitude of a bar? Root of 0 square plus 16 plus 1, that is equal to root 17. Magnitude of a bar, root of I bar coefficient 0, so 0 square 0 plus j bar coefficient minus 4, that is 14, 4 square 16 plus k, that is minus 1 whole square, that is 1, which is equal to root 17. So grad phi, what is grad phi dot a bar? Grad phi is 8I bar minus j bar minus 10k bar, the dot product with minus 4j bar minus k bar by grad I magnitude of a bar, that is equal to root 17. So making dot product 8 into 0, that is 0, minus minus plus 4, j bar dot j bar 1, so minus 1 into minus 4, that is plus 4, plus k bar dot k bar, 10 minus 10 minus 1, 10, and k bar dot k bar 1, that is equal to root 17. So that is 14 by root 17 will be the directional derivative in the direction of grad f at the point minus 1, comma 2, comma 1. So the required solution is 14 by root 7. Next one, coming to the third problem, show that the vector a bar is equal to 3y power 4 z square into I bar plus 4x cube z square into j bar minus 3x square y square into k bar is solenoidal. So when we say that a vector is solenoidal, if a bar is a solenoidal vector, which implies div a bar is equal to 0. If del dot a bar is equal to 0, then the vector is said to be solenoidal vector. So very simple. So now given what is a bar? 3y power 4 z square into I bar plus 4x cube z square into j bar minus 3x square y square into k bar. Then what is div a bar? That is del dot a bar. Del means what? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product with 3y power 4 z square I bar plus 4x cube z square into j bar plus minus 3x square y square into k bar. So how you will find I bar dot I bar 1? So dou by dou x of 3y power 4 z square plus j bar dot j bar 1 dou by dou y of 4x cube z square minus k bar dot k bar 1 dou by dou z of 3x square y square. So what it will be? The derivative is 0 and dou by dou y. Clearly we are differentiating partially with respect to x, and here the term is completely constant, y term and z term, that is 0. Here dou by dou y of the function of x and z, this is also 0, plus dou minus dou by dou z of this entire term, this is x and y term 0, so that is equal to 0. Therefore what? Div a bar is equal to 0. It is not 0 bar, it is a constant, real constant, so it is a 0. So therefore a bar is solenoidal vector. A bar is solenoidal vector. That is the solution for this given problem. Now similarly, the vector field, fourth problem, last problem. If the vector field f bar is irrotational, find the constants A, B, C, where f bar is given by this vector. Irrotational means curly f bar. Irrotational means what? Curly f bar is equal to 0 bar. So given f bar, and also find its scalar potential, and also you have to find the scalar potential. That means if curly f bar is equal to 0 bar, then there exists a scalar potential phi such that f bar is equal to grad phi. So first I am going to show that the vector is irrotational. Consider curly f bar, that is a del cross f bar, that is determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, and the function x plus 2y plus az, first one, or I can write lengthy also, bx minus 3y minus z, and last term 4x plus cy plus 2z. So I'm expanding this determinant I bar into dou by dou y of the entire term, that is c only, remaining x and z terms thus will be 0, minus j bar into dou by dou x of this one 4 only, plus k bar into dou by, I will show once again I write, this is I bar into dou by dou y of this one, that is equal to c, minus this one, dou by dou z of this one, minus of minus plus 1, dou by dou z, this is x term, this is y term, this is z term, dou by dou z of this one, minus 1, already minus is there, c plus 1. Next, minus j bar into, on discarding the middle column and first row, dou by dou x of this one, that is 4, minus dou by dou z of this one, that is e, dou by dou z of this one, x term, y term will be 0, and minus a, plus k bar into dou by, then discarding this last column and first row, you get dou by dou x of this one, dou by dou x of this one is b minus dou by dou y of this one 2 is equal to 0. So you know how to find the curl f bar, that is del cross f bar, that is cross product of the two vectors. Now it is 0 bar clearly because the vector f bar is irrotational. So each term will be 0. Each term will be 0 means c plus 1 is equal to 0 or c is equal to minus 1. That is the first value. Each coefficient will be 0. Similarly 4 minus a 0. So a is equal to 4. That is another constant a value. Similarly b minus 2 0. That is b is equal to 2. Therefore what are the values? A is equal to 4 and b is equal to 2 and c is equal to minus 1 are the values of the x, y, z, sorry, a, b, c, which are involved in the given vector f bar. And also find its scalar potential. Whenever there is curl f bar is equal to 0 bar, in that case there exists a scalar potential phi such that f bar is equal to grad phi, right? Since f bar is irrotational, there exists a scalar potential phi such that f bar is equal to grad phi. So that is I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z is equal to, what is f bar? That I will see f bar x plus 2y plus 4z into I bar, x plus 2y plus 4z into I bar plus j bar into bx minus 3y minus z, that is 2x minus 3y minus z into j bar plus k bar into 2x minus 3y minus z, 4x plus 4x minus y, 4x minus y plus 2z, 4x minus c will minus 1 minus y plus 2z is equal to this one. So on comparing both sides, the coefficient of I bar will give dou phi by dou x is equal to x plus 2y plus 4z. Similarly, what is dou phi by dou y? On comparing both sides, 2y minus 3z and, I'll write once again, dou by dou y of this one, bx, that is 2x, bx is 2x, where is it? 2x minus 3y, b is 2x minus 3y minus z, minus z. So 2x minus 3y minus z, and what is the last value? Dou phi by dou z, that is equal to 4x minus y plus 2z. But we know that by total derivative formula d phi is equal to dou phi by dou x, but d phi is equal to dx plus dou phi by dou y into dy plus dou phi by dou z into dz. That is dou phi by dou x is x plus 2y plus 4z into dx plus dou phi by dou y 2x minus 3y minus z into dy plus dou phi by dou z, that is 4x minus y plus 2z of dz, and this is equal to d phi. So what you will get here is x dx is one term, x dx. Similarly minus 3y dy, here minus 3y dy plus 2z dz, remaining terms 2y dx plus 4z dx minus z dy plus minus z dy minus 2x dy also there, minus z dy minus 2x dy, and here 4x dz minus y dz is equal to d phi. So on integrating, you will get the required solution. Integral x dx, integral 3y dy, integral 2z dz, integral t2y dx, y dx plus. We can write the terms which are involved in one set, and you can find the solution. That will be the final solution of the given problem. D phi is final solution of the given problem. So this problems has been taken from the question bank of the course. differential equations and vector calculus, and which is the syllabus, the regulations is BT 23, published by IARE. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.